To verify the Bernoulli theorem experimentally, there is a setup through which we can verify the Bernoulli theorem. This setup consists of motor of half an horsepower coupled with a centrifugal pump. A nut is provided for priming. Motor can be switched on or off with the help of this button. This is an outlet pipe of the pump. This is the inlet pipe of the pump. Inlet pipe is connected to sump, or it is also called recyclable tank, because it recirculates the water. Water from this recyclable tank through this pump goes to this inlet pipe to this inlet supply chamber, and flow rate in this chamber can be controlled by this valve. There is an overflow pipe which helps in maintaining the constant water level in this chamber by discharging the excess water through this overflow pipe into this recyclable tank. This is a converging diverging duct. This converging diverging duct is having different cross-sectional area by having different height and constant width. One side of the converging diverging duct is fitted with 11 number of piezometers, which measures the static pressure at 11 different points on this converging diverging duct. Outlet of this duct is connected to outlet chamber. This outlet chamber is also fitted with piezometric scale. One can measure the height of water level in this chamber also. Water through this pipe goes into this measuring tank, and flow rate through this converging diverging duct can be controlled with the help of this outlet valve. This is a discharge measuring tank having 30 cm length and 30 cm width. Is used for measuring the flow rate. Once flow rate is measured, then outlet is opened and water goes into recyclable tank, which is recycled by pump. Switch on the motor. Water will start rising in this inlet supply tank. In this particular condition, the outlet valve is kept at fully open position. With the help of this inlet valve and this outlet valve, the water level in this chamber is made constant. Under this condition, water flows through this converging diverging duct, which is fitted with these piezometers. There are 11 piezometers. On the back of these piezometers we have scales, and with the help of these scales we can measure the height in the individual piezometric tubes. These heights gives us the pressure head at different cross section. So what we do, these heights in these tubes are measured at constant level. So first there is need to make the water level in these tubes constant. So these readings in these tubes are taken only when the level of the water in these tubes become constant. Then water comes out in this chamber. After that it is going in this measuring tank, which is having length and width equal to 30 centimeter and 30 centimeter, which is used for measuring the discharge or flow rate through the duct. With the help of piezometric scale fitted on measuring tank. For measuring the flow rate, close this valve and note down the initial reading and start the stopwatch. Water level will rise in this measuring tank. It is rising, and after 30 seconds note down the final reading. These are the observations which are required to conduct this experiment. After this, open this valve, fluid goes into sump or recyclable tank. Close this valve little bit for changing the flow rate through the duct, and repeat the whole experiment again. There is a precaution that bubbles of air should not be in piezometric tubes as well as in this converging duct. This bubble does not give the correct reading of the pressure head.